Hello and good morning, good evening, good afternoon to everybody. Thank you for joining. Hello, Tomasz, and welcome to the
Hey,
stream. Hey, how's it going? How are you doing?
good. You?
You're good. Yeah, good. I'm looking forward to this. I think this is today. I'm pretty excited. We talked about this. I think end of last year when you published your blog post, and it was just about the fourth Matrix movie was coming out into the cinemas, and I was like, yeah, this is a cool topic.
Mm.
Let's do this. So I'm pretty
Did,
excited.
did you watch the movie?
I did not watch the movie yet, so I haven't watched
I,
it yet. So
I
I
mean,
kind of wanted and I missed out.
you're not missing anything because, like, I was watching the movie at home, and then, like, almost at the end, I decided I and went to clean my kitchen
Oh,
while the movie was
oh no,
running. Yeah. So like for the last 30 minutes of the movie, I was cleaning my kitchen. So
that's not a good sign. If you, I mean, if I have like a ranking of things to do, like cleaning the house or the apartment is like down here. So anything other than cleaning is usually better. So if watching the movie made you do cleaning, then I guess it's not
yeah,
very good.
it's not. It doesn't live
Oh
up to the
no,
hype, but
no, maybe not. Maybe not.
okay.
Yeah, I mean, let us know in
Um,
chat if you watch the movie and you disagree with Tomasz or if you agree with him. If you think I should definitely watch it, also write it in chat. I probably will eventually. I got the first one on Blu-ray just before Christmas, and I watched it. Oh, it's still
uh,
good. It holds up tremendously well. So I'm
yeah, I mean the first
yeah,
one is like a lot of nostalgia, and I
yeah,
feel it's the best one of the series probably.
yeah, yeah.
Okay, so maybe I should share my
Yeah,
screen.
let's dive in.
Let's
We
dive in.
what we do today is we gonna yeah, you have your blog post open. Maybe I'll switch
Can
over
you
to
see?
here. It's perfect. And then
Okay.
let me get rid of this. So yeah, this is the blog post. I will put it in chat in a second. So this is Thomas wrote this, like you see here, 16th of December.
Mm,
And this is also defining the topic of our session today: construct the matrix interaction network based on the movie script. So maybe Thomas, do you wanna give a
mm.
quick
Yeah,
summary?
I can give like as I suggest. So basically, we'll like I can show the end result first. So this is the end result. So basically, we've got entities in the Matrix movie,
Mhm.
like Neo, Trinity, Morpheus, and relationships between them are weighted by how many scenes they appeared or co-occurred together. So here, for example, you can see that Morpheus, Neo, Trinity have larger like border points between them. So that means they interacted more. And like for example, Trinity and Mouse didn't interact that much.
Mhm.
And then once we've created this network, what we can basically do is you can see that the nodes are colored, and I didn't color them manually, even though some might it might look like this because the results are really nice. But I used a community detection algorithm to basically find communities in the network like unsupervised, so you don't tell the algorithm what you're looking for.
Mhm.
You're just telling him find me communities of various nodes in this case. Um, and I thought that the results came like really nice because the yellow one are the Nebuchadnezzar gang. So basically, the all the guys that are on the ship,
Hmm.
the yellow ones, and then we have the purple ones who are the agents, and I don't really know who's the lieutenant. Um, and then the orange one are the Oracle and her gang, right?
Yep.
So the results came. I was like pleasantly surprised how well the results I got. So yeah, so these are the end results, and then we'll see how we get there, right? So how we get there is first we'll scrap the matrix fandom page with Selenium. So basically, we will identify which are all the characters in the first matrix movie. So here we have a list of all the characters in the movie, right? And we'll also do some additional enrichment because here, for example, you can scrape some additional data. And that's like the first step, so that we
Hmm.
know all the characters that appeared in the Matrix movie. And then for the second step, the Matrix script is available online for educational purposes, which is really nice. So it's I say 130 pages long, but basically it's like exactly what you would imagine a movie script looks like. So here you have like the name of the scene, and then some introductionary, and then whenever some character is talking, right? They are in bold and their line, and then like their bold and their line. Uh, and obviously there are multiple movie scenes. And what we'll do, because like I said, like also the title is co-occurrence network, right? Constructing a
Hmm.
co-occurrence network. So we'll identify first, we'll identify all the scenes in the movie and split the text by the scenes. And in the next step, we'll identify all the characters that appeared in that scene. So then we know, like, if we know all the characters that appeared in the scenes, then we can easily compute like how many characters appeared in the same scenes and in like how many scenes they appeared together, right? So this is basically the agenda.
Hmm.
And if you want to follow along, I've got also a notebook. So basically, you can, it's a Google Colab. If you can share that.
Yep.
Um, so if you want to follow along, I prepared a Colab notebook, and
Put in chat.
it it makes sense. If you want, you can create a blank project in Neo4j sandbox so that we have some place to store the data set, right? So you just go, you just type, you just Google Neo4j sandbox, log in, mhm, and open and start with a blank sandbox because we don't want any data set to be pre-populated in the instance. And then you just create it, and it takes like a couple of seconds, and then we are ready to go. Here basically what you'll need is the connection details, so but we'll get to that in a second. So basically, the first thing we need to do is install all the dependencies. Obviously, I like to give like collab notebooks because usually setting up all the dependencies can be a pain in the ass. Yeah, I mean, like even locally, it's like, yeah, it can be a big pain in the ass, and so that's why my preferred method of sharing code is Google Colab or like Dockers, because the basically like lots of times when I'm doing when I'm following other tutorials, like if I don't get my dependencies set up in a minute or like in 5 to 10 minutes, then I will just give up, like
Yeah. Yeah.
because
No.
it's
Yeah. Yeah. If it's just for something to try out and to see if how that works and how that looks like, you don't want to spend half an hour to get everything ready by.
yeah, because
Yeah.
like even like, and this is the biggest pain in the ass, like with like academic, because now the it's really cool that academia posts like its code on GitHub, right?
Hmm.
But then getting it to work, like if it's like a year or 2 years old, like I will say that if it something works like out of the box, I'm like very surprised.
Yeah.
So can you paste the link of Neo4j sandbox? So
Yeah,
basically, what you just
let me. Yeah.
do, oh, you can basically, or you can just Google Neo4j sandbox and open a blank project. I feel like there's there could be like an URL, but and I think I remember the Google Colab needs to be restarted after I install the dependencies, but I'm just gonna do it because I think you just have to restart the runtime because of SpaCy. When you download the SpaCy model, for some reason it needs to restart. And let me just set up the Selenium again, because I think I remember, but there usually I would let's see, restart. No, but for some reason I remember I had to restart. But yeah, but like anyway, now we can get started, right? Mhm.
Hmm.
So basically, like I showed, we're gonna check this page, not this one, and we're gonna scrape all the entities and their URLs in the first step. And for some reason, Trinity is not included, which, which is like not the best thing to have, like when you're doing a fandom and you don't include Trinity in the character list. But first, but like there's some sort of bug, but I don't know why, and like it's not my job to fix it, right? But here appearances, she appeared like as I remember. So here under her appearances, she appeared in the matrix, but in the characters, you can see T, she's not included. But yeah, so I just
Strange.
manually
But yeah. Okay.
manually included Trinity. And let's okay, so we have it. So basically, if you want to check what we have under the member list, basically we have names and URLs of the entities, right? Because now we're gonna use these entities, these entity URLs, and enrich some information about characters. Because, like I said, if you check, for example, Neo, here you've got like a real name, nickname, hacker name, age, birth date, all sorts of things, workplace, right?
Mm-hmm.
And hopefully this still works. So we're gonna fetch that information. Mm.
Do you grab all of it or just a couple of the?
No, all of it,
Mm-hmm.
because it's a table, right?
Yes.
And the here we can see that basically the HTML looks like
Ah,
this.
yeah. Now I understand. You take the yeah. Mm-hmm.
Yeah, because you gotta fetch. So let me uh, please work. So this is basically what you're doing when you're scraping. So basically the whole cell is p item, p data. I used p data,
Mm-hmm.
and then the h3 is the key, right? And the div is the value. So basically, you just look for any um, cells that have a class p data and just fetch all of them because various characters have various information, right? And we want to have something generic, right?
Yeah. Yeah.
Uh,
That makes sense.
so this is, I don't remember how long this takes. But what we can do in the meantime is set up the connection to Neo4j. So basically, we created the blank sandbox, and we can just copy the information from the sandbox, right? Just so we have the connection set up. And it seems like the scraping finished. So, for example, if we say member list, if we print it again, you can now see, for example, the name, which is
The second line, Spoon Boy, apparently. I don't
where do
remember.
you see
The second
allies
line
appearances?
under hair color,
Aha,
the
name.
second.
Aha, that's the previous one. So it's like
Yeah.
name is the Spoon Boy. He's
Yeah.
affiliated with the Oracle. He's
Yeah.
male. He's bald. Oh, here it was. It was switch, right? And for switch, we know some more information, right?
Ah,
His
yeah. Okay.
enemies with Cypher.
Yeah.
But this is basically what happened later, right? Because Cypher killed, and my did
Cypher,
well in.
I think he got killed.
Oh, Cypher got, yeah,
Yeah.
Cypher
Yeah.
got Switch defected, right? And he
Yeah. Yeah.
wanted
Exactly.
the steak.
This yeah.
He wanted to feel the joy
Yeah.
of the steak. Mm. So yeah, this is the information that we scraped, and we could do some like pre-processing, but we can do that also in Neo4j. So
Mhm.
now that I've set up my connection, right, we can just input the data set into the
Sandbox.
sandbox. Yeah, exactly. So here, if we open browser, we should have some nodes in the graph, and we'll explore a little bit and maybe play around because The OCR for the movie script, it's 130 pages, right? So it takes around 15 minutes. So we've got some downtime
Mm-hmm.
to play around. So maybe we'll look at the data. Uh, let's just see if the data is in, and then I will run basically the OCR, and then we'll come back to the data. So, okay, we've got 33 characters and no relationships, uh, and a bunch of properties, right? So
Okay.
we know some mother. Let's see where exists mother. I'm interesting. Very and just return. And oh, Neo, we know who is his mother. What?
Well, I don't know.
So his mother is Michelle. What? I have to Google this out of curiosity. It's like here, yeah, mother Michelle McGahey. Seems like
Okay.
mother of Neo,
I don't.
art director of the Matrix.
Okay. Well,
So she's got like an
this
honorable
honorable man. Yeah.
honorable mention.
Yeah.
Or maybe let me just turn on the light. She's got.
I don't think this is of any. I mean, they are. I don't know if the concept of
Yeah,
you remember the movie. I don't think this is really mother, but yeah, of course, sure. I mean,
yeah.
why
Maybe
not?
this is only like fandom because we also
Yeah,
have
yeah, maybe.
Father John Anderson. Okay, this makes a little bit more sense because it at least the same
Yeah,
last name, right?
yeah, true.
It's the other king here. Sorry, guy, I don't have professional streaming
That's okay.
equipment, so there's no light
Yeah.
in front of me. But yeah, we'll look at the data a little bit more. But first, we will just run the OCR
Hmm.
because, like I said, it takes like 15 minutes. So let me just run it. So basically, what we do is download, like I said, the movie script,
Hmm.
and basically, if I understand correctly, is we then transform the PDF into a series of images with the
Okay.
PDF to image, and then we use the Tesseract, which is the famous Google's library for OCR, so this optical character recognition, I think. Yeah, yeah, optical character recognition. So basically, we are recognizing the text in the images, right?
Hmm.
And then basically we just join the text from all the images together so that we get a sequence of basically so that all the text is joined into a single variable under a single variable.
Okay. And
So
is this then is the output a text file or where does the
just basically a string, so it's
a
just
string? Okay.
a variable with a long string, basically.
Okay. It's a very long
So
string then. Okay.
I
Yeah.
even mentioned. So
Yeah. Okay.
it takes 15 minutes, so you can take a break and stretch your legs. But we won't be doing this
No, not
at
now.
the moment. So we've got a question. Can we do time series analysis where we can measure the impact of feature importance over time? If you have any articles regarding the same, please do share. So basically what we can do is, how do you say, in like what I've seen or what I've done with graphs is, I can show you because I've written that. And let me just. So basically, you just take like a window of time and like move along the time. If that makes sense. I don't know. That doesn't really make sense, but I'll show you an example, and then you'll
You mean
see.
snapshots?
Yeah, basically snapshots of time. So for example, when you're doing like time series, like you could do here in this specific example, you could take like 5 scenes and do your first analysis on the first 5 scenes, and then the second analysis, the second step of the analysis on the on like from fifth to 10th scene, right? And
Hmm.
just have a sliding. I don't know if the sliding window is the best word for it, but I feel like, and I can show you how I did. I basically did it with the Game of Thrones. I think it should be here. Come community action to the time. Um, so basically, here for the Game of Thrones is you basically take the first in this example, it's basically the book, but you take the first book, the second book, the third, and the fourth book is usually used together, and you just say, okay, like our sliding window is one book, but like you have the option of changing that to however you feel like. So maybe if Alex will share that with
Yep.
you, you can take a look. But basically, I can show you some images. So it's basically okay. So the first book, but I feel like something is missing. It's not. It's not. They're not all characters. But yeah. I've just looked at a single community from the first book, and then looked how it expanded to other books, right? So
Hmm.
this is like the community from Daenerys Targaryen, and I've included her communities and basically all the links that the community has with other communities, right? So, for example, Daenerys Targaryen in the first book was basically there are a couple of people who talked about it. Nobody really met her, but yeah. And then like this is like the second book, so it
Hmm.
grows a little bit, and then in the oh yeah, this is like the third book, so the community grows again, and the fourth and the fifth big book is basically it gets larger. So this is basically the how to say the process or like the approach I've seen with analyzing time series in graph is basically you take like a sliding window
Hmm.
and like iterate over the whole timeline. I don't know if that answers your question, but like when you're saying feature importance, you should maybe Google uh, because like some German students, if I remember correctly, try to predict who dies in the next. But I think they did it for the TV shows. But it's basically you take because you want to see features, right? You basically take the features from like the first series and try to predict who's gonna die in the second series, right? And if you want some feature importance, you can like use like Scikit, and it will try to explain which features are the most important. Okay, so back to the matrix. This is running, and like I said, we can take a
Yeah,
look
let's have a look at the
at the data set.
yeah.
So, for example, what I didn't do in the article, but what we can do is for basically turn some properties into relationships, for example. So let's look at people who have allies where exist see allies, just to get a feeling how many of them are. So we got 12, and then just I think they are splitted by white by new line characters, but so just let's check with C. Then we do split C allies by new line S allies and return allies. Just to see, yeah. Okay, so
So now you
you get,
created a
yeah.
table.
So
Yeah,
so
okay.
you can do, for example, I could see name. So now that we could turn it into relationships, right? I'm just checking if the syntax or the formatting is correct.
Mhm.
It seems like sometimes the only problem I see that Cypher has Smith, otherwise it's Agent Smith. But other than that, shouldn't be a big problem. Neo for
Yeah, was that
Neo,
switch?
I said Neo4j. Neo has a lot of allies.
Yeah. I
I
guess
have,
the was that Smith or Switch? Oh no, allies does not make sense for Cypher. No, he was.
yeah, Cypher. Oh, he's not even included. Yeah, because the thing is with these
Yeah,
types of uh, tables, right? There's no like point in time, right?
yeah, yeah, yeah.
So even when you look, let me find Neo. Even he's like his spouse or wife is already a romance as Trinity. But yeah, I
Yeah.
feel like maybe that's also valid for the first book as well, for the first movie as well. Uh, but yeah, so the thing is that it's not no. So because who is the cipher switched, right?
Yeah.
Cipher.
No,
So
Cypher was killed by. Oh no, Cypher switched. Yes, you're right.
Cypher,
Yeah,
so yeah, because we
yeah,
can. I
yeah, yeah.
remember
That's
his
a,
face.
yeah, yeah, exactly. Yeah,
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 so you can see he's like the defected.
yeah, yeah,
Uh,
yeah.
he's the defected cipher. So his enemies, you know. And if someone changed this to Agent Smith, it would be nice. But yeah, it is what it is.
Yeah,
So now what we can do, like we can see that there are some new characters that are not um, present in our character list. So we have the option:
yeah,
do we want to create new characters in our data set, or we don't want to create new characters in our data set? And I will choose not creating because I don't want, because basically it will mess up a nice visualization. So
Yeah.
that's the
I
only
guess the
reason.
characters that are not in the list are just some minor.
Yeah, minor or like from second or third.
Or exactly, yes, from the other movies.
Uh,
Yeah.
um, so so we will ignore them here,
Hmm.
and we'll just say unwind allies as ally, and then we'll match a character name ally, and we can do merge C ally. Or, yeah, it's fine. Ally with A. And hopefully this works. So we got 64 relationships,
No, and we got a new relationship type. Yeah.
and if you take a look, I don't know why Agent Smith is allied with Neo or
Mm,
Trinity. But like other than that,
yeah.
it looks okay because here we've got the bad
Yeah.
guys and here we've got the good guys. And oh, maybe I don't know. This is from the third to the fourth
Maybe I don't.
movie because
I don't.
Agent Smith then kind of became a renegade and he became more friendly with Neo because basically Neo transferred Agent Smith, right? But who knows exactly what's the logic?
Yeah.
Because basically, I mean, this
That
is
doesn't
what you
say.
get.
Yeah,
This
that's
is
what you
what
get
you
from here.
get
Yeah.
when you crowdsource data, right?
Yeah. 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 I guess that it's true.
Uh, so luckily, this finished
Hmm.
after 13 minutes. And I did a little bit of cleaning. So basically, I removed the title and I removed continued if the line starts with continued. That I just ignore the line.
Yeah.
A bit of cleaning, exactly. And if you want, you can download the script in the text file, exactly. And like so if you don't want to rerun OCR,
Hmm.
but here we don't really need that, right? So
Yeah.
now we need to split by scenes the text, right? And
Yes.
how I did, like at first I really was hoping to use these numbers because here you can see one. So this is the first scene. Okay, and it's continued, but whatever. And then you see two,
Yeah.
and it's the second scene, right? But unfortunately, the OCR doesn't recognize these numbers.
Ah.
So
Shame.
yeah, I spent some time trying to make it work, but the OCR didn't listen to me.
Okay. It just takes the text in the center
Yeah,
and
he
not the
just takes
column.
the text, but doesn't like this, and some of these ones he takes, and some of them he doesn't.
Ah. Okay.
Uh,
I see.
yeah, but like, because I've tried many models and I've tried various settings, right?
Hmm.
Because I really wanted, because I didn't know how to split by scene otherwise.
Yeah.
But then, like, once I gave up, I realized basically that all the scene names start with like interior or exterior, and you've got interior and exterior and interior
Hmm.
and interior exterior.
Yeah.
So luckily, I found a way to split the text by scenes without these supporting numbers, which I was really happy about. Mm, Yeah, and if there are some scenes that are omitted, so there was, how to say, like, is it only one M? Yeah, only one M. There was some, and maybe two T's. Yeah. There are
Yes.
some scenes that are omitted, right? So someone had to do a review
Yeah.
and
Okay.
said this is not going to work, or something like that.
So it was
uh,
cut from the movie in the end.
yeah, probably.
Yeah.
Mm. So we're gonna skip these lines, right, because they don't bring any value. So let us do that. Okay, so now that we got,
So
I
you
think,
you 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 look for int and then or x and then whatever
yeah,
it
yeah,
is.
if
It's
int
yeah.
or x,
Yeah.
I also added the end because I don't want, there are some things that are uh, after the end, but I don't want it. So here you can see, so this is scene names, right?
Oh, and it
Int
gives you
x.
alternatives. Okay,
Int.
cool. Yeah.
Mm, and now we have to identify all the characters in the scenes. Um
Yep.
and I used SpaCy because I didn't use NLP per se because we don't really need like to identify characters. Like, how would I say? We know what we're looking for, right? Because we scraped the fandom, and so we know which characters we are looking for.
Hmm.
And in the movie script, luckily, they have standard names.
Yeah.
So
Yeah.
there's not a big deal of having to find characters.
It's a bit
So
more straightforward than a scientific paper.
yeah. So basically, I used SpaCy rule-based pattern. So basically, and I for every character, so basically I ignored the, because we have the only one that is the oracle, right? And I
Hmm.
just want to look for oracles, but it either has to be uppercase. So when it's uppercase, it's basically the character is talking, or if it's title cased, right, then it's
Ah, yeah, that's clever. Yeah.
in the text.
Yeah.
And we define the pattern for every character, and then hopefully this will work.
So you
Uh,
basically decide, you know, who is talking and who is being talked to,
yeah, yeah,
or
yeah, but we don't
yeah.
really care. We
Mhm.
could like differentiate who is talking and being who is mentioned, basically.
Yes, mentioned exactly. Yeah.
We could differentiate, but I didn't go that far.
Hmm.
I just basically said if a character is mentioned or appeared in a scene, we'll just say that he is part of the scene.
Okay.
Um, and I feel like, yeah, this is how easy it is. So basically, what we now do is iterate our scenes and scene names because we will store them into the graph
Hmm.
and just find all the characters uh, in the scene. We create a set, right? Because we don't count. We just want to know if a character is present or not. We don't care
Hmm.
how many times or whatever. We
Yeah.
could do that, but we don't really care. And then we just store the results in the database.
Yeah.
So
Because yeah, I guess you're right. For us, it does not really
I
matter
mean,
how. Yeah. Yeah.
there are like lots of variations that you could do, right? You could
Hmm.
like say who is mentioned, who is talking, right, and differentiate between that. You could say how many times a character is mentioned or how many times a character is talking, right, and do
Yes.
some sort of weights.
Yeah.
There are possibilities, obviously, that you could do, but I tried to make it simple because I didn't find any additional value
Yeah.
for that.
But I mean,
So this,
the code is here. So if anybody wants to elaborate and take this one further, like you said, find out how many, how how often somebody speaks or how often somebody's mentioned, then I guess instead of taking, you can
yeah,
take
you
it
can
from there
basically
and
you could here just
change it.
basically here change the pattern, right? Because here
Yeah.
I just say I just lump them under the same pattern, but you
Yeah.
can
You could.
differentiate
Yes. Exactly.
if you
Yeah.
really wanted to.
Yeah.
So it took a minute, and now we've got
Right. Okay. Now we got scenes in the database.
scenes and characters in the scenes, right?
Hmm.
So if we say,
So again, the orange ones are the characters and the blue ones are the scenes.
yeah,
So we
so
now
for
have
example,
car 23.
yeah, in the card 23. So for
Yeah.
example, this for characters, how this, yeah, for the characters appeared in this scene, right? So we
Yeah.
can then we can just say, oh, I did some like exploratory analysis where I say, so which are the characters that weren't in any scenes, right? And these are the characters, so I don't really know who any of them are, except for the
Mm,
woman in red.
woman in red.
But
Are they
it's not. It's
these are mentioned in scene and
no. These are
or are these
mentioned in here, but we haven't identified them to appear in any scene, right?
I see. Okay.
And I feel like I have no idea who these are. I mean, law enforcement and SWAT security
Yeah, some
guards. Who
police
cares,
guys and
right?
security guards. Yeah,
And who's
exactly.
Austin? Nobody knows,
Well, I don't know
right?
if you know who's Austin. Let us know in chat. I have honestly no idea who Austin is, but maybe yeah, like you said, crowdsourced. So maybe some of the
I mean, we
community
can
team
check
have.
who's Austin, right?
Oh, he
Here.
has got an open page
Yeah, so Austin is a member of the
of the
police
police
force
force. Okay.
and was, yeah, I mean, who cares about him,
Yeah.
right?
Okay. Well then.
And now we can check which characters appeared in most scenes.
Oh yeah. Okay.
So this makes sense, right?
Yeah. So
Mm,
this, yeah, exactly. This is talk now. Now, like we said before, this now includes everybody in all the scenes. So we say even even if Neo is not appearing in the scenes, but he's mentioned, he's still counted in here.
yes, exactly.
Yeah.
Mhm.
Yeah.
So
But of
yeah,
course, makes
Neo
sense. Yeah.
is the main guy, right? And then Morpheus and Trinity, with Morpheus having a slightly more
Yeah.
impact. Yeah, and then all the other
Hank.
guys.
Let's be
And
fair.
like you can check which characters co-occur between each other the most.
Hmm.
So Morpheus and Neo appeared in 59 scenes together.
Yeah. Also
Neo and
makes sense.
Trinity in 55. So basically, the three main guys are Morpheus, Neo, and Trinity. Although Morpheus and Trinity, it's like Neo with Morpheus or Neo with Trinity, it seems, but not so much Morpheus. All of three together, or just Morpheus and Trinity.
Yeah.
Um, but yeah, and then basically, obviously, the good guys, right? The good
Yeah.
gang.
Yeah.
And like I said, we can store this information. Like, so we know Morpheus and Neo appeared in 59 scenes together. So what we can do is also store this information as a relationship between them, right?
Hmm.
So this is basically what it means. Constructing a co-occurrence network is exactly this. You take some co-occurrence event, like they appeared in the same scene or in the same movie or in the same sentence or in the same article or whatever you feel like,
Mhm.
and just count how many times they appeared together, two entities or two nodes, and then just store the number of co-occurrence between two entities as the relationship between them, right? So, and this is basically a co-occurrence network. And here we say, I named it like interact. So, for
Yeah.
example, Neo and Choi, whoever that is, interacted one time.
Yeah.
And like, for example, I really don't like the allies. So let's do this. Mm. And for example, Agent Brown and Neo interacted in seven scenes, basically
Seven
appeared
seats.
in
Okay.
seven scenes
Yeah.
together. And now to create a beautiful visualization, we will use the Graph Data Science library and we'll run PageRank and Louvain, which is community detection algorithm. I don't have time to go into it.
Hmm.
But you can check out other posts. I think Claire has a nice video series.
Claire has a super good video series. I will post a link to that in the chat because that's a
Chat.
really good one.
Yeah, so if you want, but basically Neo4j's got a plugin with it's called Graph Data Science, and it's got a bunch of algorithms in it included. So maybe there's a nice picture. Okay, so here's one picture. So yeah, this is probably outdated a little bit, but
A little bit, but it doesn't matter.
it
So
doesn't matter that much. But
yeah.
you've got like pet finding, centrality, community detection, link prediction, similarity, embeddings, and there's also some machine learning capabilities in it as well at the moment. And so yeah,
I'll also
it's
post
a
post a link to the yeah.
yeah, so that's cool. And I suggest you take a look. And like now, how I created this image is basically I used Neo4j Bloom. So Neo4j Bloom is included as in the sandbox, so you can open any sandbox, as you can see, with browser or with Bloom or with Neuler. And we're gonna open with Bloom. And hopefully, I think I need to copy the passwords. So username is Neo4j, password is this. Quickly, 1 second. Okay.
Yeah. Sometimes it takes a little bit.
Okay, we got it.
Here we go. Yes.
So we need to create a perspective and we just say do it yourself. So basically what perspective is just identifies node labels, relationship types, stuff like that.
Yeah. And here we are.
So here we are, and we want basically to visualize all the interacts relationships, and we don't care what's on either side because we know there could be only character, right?
Yeah. And that's very easy with Bloom because it gives you a couple suggestions. You don't even have to type anything
Mm,
in the search box, and you
yeah, it's called how do you say near? They call it near natural language search or something like that. Basically, you
Mhm.
don't need to know Cipher, and
No,
it
you don't
allows
need. Yeah, exactly.
exploring. So basically
Yeah, and here
here
we
is
have all the
here we
characters.
have a graph,
Mhm.
and now we can color it based on community, for example. So here we've got like you click on the basically yellow node on the circle that's near the node label, I would say, and then check the rule based. And here we've got a bunch of options, and we really want Louvain. Doesn't work, but at least hopefully it's by alphabet. So yeah, it is. And we say unique values, apply color.
Hmm.
So now the nodes are colored by the community, and as you can see, I didn't do any manual interventions. This is what we get, right?
Yeah.
So imagine, I feel like it's a really powerful tool because what we took 130 pages of movie scripts. Who's gonna read that? Nobody. And we just say, okay, now let's do a summary. Let's do a summary, and this is the summary of the script,
Yeah.
right?
Uh, Even if you have
And
not watched the movie at all, you know, okay, the yellow ones are one group, they belong together. The purple ones are
yeah,
one group,
maybe
they
this would be like a good idea, like for high school students. Like
yeah,
we need a summary, and
yeah,
you're
yeah,
like, okay.
yeah,
And like we can
yeah,
also do the size by page rank, right? So it should be range, size, apply size, and you can play around how big or small you want the nodes to be. So let's say you can see like just by looking at the visualization that Neo is the most important, it seems, and then Morpheus
absolutely.
Trinity,
Yeah.
and then some people around it, and those who don't have their names in the caption, they're not important, right? I mean, you can zoom in a little bit, and their names will appear. But like, if you see security guard, so nobody really cares about security
No.
guard. And what you can also do is because we've got the weight of the relationship, right? And we can apply the color size, and I prefer to do the size, right? And so here now we've applied the rule to for the relationships as well. So the higher the relationship weight, the bigger it is in the visualization, right? So you can see like also, so Neo4j, I'm again.
Yeah.
Neo
It
interacted the
happens.
most with Morpheus, right? And Trinity just by looking at this image. You don't really need to to know anything more. And if you want to, for example, find who Oracle interacted the most,
Yeah.
for me, it seems like it's this one to Neo, right? But it's not so obvious. But
Yeah.
I
I wonder
feel
what somebody would write if they got this and then say, give me a summary of what you think is happening in that movie. You know, Neo and
mm,
Morpheus are good friends, and I
yeah,
don't know. They
yeah,
would become like a medieval story. They go together on a hunt to visit the oracle, and then
yeah. And Trinity is hurt in the woods, and
exactly, it's a damsel
Neo
in distress.
saves her. Neo saves her.
Yeah.
So yeah, basically this is like the whole process. I also did something similar for Harry Potter, but I didn't create such a beautiful visualization. But basically, you can apply this to any. It's like popular to do for books or TV series or movies.
Hmm.
because it's like really cool and just like such a simple technique, right? And you get very nice results. Like, as I feel like these are like
This is
really nice,
super. I mean, yeah,
really
like you
nice.
said, right? We didn't add any additional information. We just scraped the text and put it in, and let the algorithms do their magic,
That,
basically. And here you go.
yeah,
I mean,
exactly. It's like basically unsupervised. We had no input to say what is important, what to look for,
yes,
what we want to get out. We didn't do anything, right? We just said, so here is basically the co-occurrence. Now, please tell me something about it. And algorithms automatically told us something about it.
yeah,
So I can also do a shameless plug.
absolutely, do that.
A shameless plug. So I'm also writing a book uh, about graph algorithms, and I'll
Hmm.
also include something about NLP. And it's called Graph Algorithm for Data Science. It's available on Manning.
Yeah. Do you?
I've got
Can you share the link with me so I can put it in chat?
okay. I can share
Yeah.
the link. I've got a
Thank you.
special code. It is interesting, but they shared a special code with me.
Yeah, totally.
It's only 35% off because here it is by default it's 30%. But it's 35% off for all the and if I believe correctly, it's not just for my book, but it's for all the products on Manning, right? So
Sure.
even if you don't like my book or you don't find it interesting, you can find something else on Manning because
They have got other books about
they've
Neo4j. So
got other
if you
books as
don't
well.
like Tomas' book, but I recommend Tomas' book. He's a great author, and he written
Yeah.
lots of interesting articles on Medium. So
Yeah, maybe
definitely,
we can also do the shameless medium. So basically, if you want similar articles, if you want to read them, you can follow me on Medium.
yeah.
I
Follow
can
Tomas definitely. I would recommend.
and it because
He's
here,
written
like, I
lots of
mean,
things. Yeah.
we did like something similar, like using NLP and knowledge graphs, and basically we are monitoring like cryptocurrencies, for example, and we did like a bunch of cool stuff, like exploring NFT transactions,
Yeah.
and there's like a lot of cool stuff. So if you're interested in like knowledge graphs, NLP, but also like graph machine learning, you can definitely follow me on Medium. Like I publish mostly on Medium, so that's the best place to look for my content. And if you like it, definitely follow me and let me know how do you feel, or like if there is any content that you would like to see, do let me know, and we'll see how it goes.
Yeah, that's cool. And maybe we do another episode here with that content or that suggestion. So definitely.
Mm.
Thank you, Tomasz. I think that is it for today. Definitely follow Tomasz on Medium, on Twitter. Check out his book. The links are in the chat, so definitely have a look at that. Thank you, Tomasz, for joining today and for taking the time to go through this. Thank you very much for writing all these amazing articles. So really, I mean, you can see he's almost like a machine. I mean, 10th of January, 19th of January, 25th of January. So three great articles within I don't know 15 days. I don't know how you do it, but it's really good. It's really
Yeah,
good.
thanks.
Yeah.
Yeah.
Yeah, with that, I think we're done for today. Thank you for watching. We will be back next week on Monday, Michael and I, on our Discover Neo4j or DB live streams. Um, yeah, I hope to
And
see you then.
yeah, and
Pardon?
maybe we'll do another one.
Yes, I'm always open. I'm happy to do another one, either on one of your other
Post.
posts,
Yeah, or
and
we can write a new one.
we can write
Right.
a new one. Yeah, exactly. Yeah.
Okay.
I'm looking forward to that. That was really cool today. Thank you again. And yeah, with that, thank you all for watching. Wish you all a great day, rest of your day, evening, afternoon, or morning, depends. And yeah,
Yeah.
see you soon.
You.
Thank you.
Okay. Bye.